Okay, mathematicians, we're on Unit 7, Lesson 5. And our focus for today's lesson is to locate, oops, let me write the word focus here. Okay, we want to locate and plot points in the first quadrant of the coordinate plane. Okay, this is our focus, so let's understand what that means. Locate means we want to find. Plot means that we're going to actually find the spot where it goes and mark it. So we're going to mark something on our plane. The point is just like a period, like the location that we're going to mark, so it's just a dot. The first quadrant, when you're looking at the coordinate plane, which this is this last part, coordinate plane, there's 4 quadrants in a coordinate plane. We're looking in the first quadrant, which is right here. Horizontal line is your x-axis. The vertical line is your y-axis. And so the reason this is the first quadrant over here is because these are positive numbers of x and positive numbers of y. So these are all positive numbers that we're working with over here. In the second quadrant, we'd have positive x numbers but negative y numbers. In the third quadrant, we'd have negative x and negative y. And in the fourth, we'd have negative x and positive y. So just to give you some background on the coordinate plane, that's why we start here in the first quadrant, because we're starting with both positive numbers. Okay. So over here on our student activity book, which is page 249, we have a coordinate plane is formed by the intersection of a horizontal number line called the x-axis, which is right here in this picture. Horizontal, remember, goes like the horizon in the ocean. Okay. And that's called the x-axis. So it's just like a number line. If you notice, we start at 0 and we build 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And notice there's an arrow here at the end because it could go on as long as we need it to in the positive direction. And then the vertical line is the y-axis. Again, notice there's the arrow at the end, so it could go in that direction forever and ever. And again, just like a vertical number line, starts at 0 and then goes up numbers. Okay. So what we're going to look at today is ordered pairs. And an ordered pair has parentheses. Just like this. And we always start with the x number first and the y number second. So you can remember that just because that's the way it happens in the alphabet too. X comes right before y, x, y, z. So x is first, y is second. So we always find the x first, which is the horizontal line. We always find that number first. And then we go up or down depending on if it's a positive or negative number. In this case, it's always going to be positive. So we're going to have a positive, and then we're going to go up a positive number as well. Okay. So this is an ordered pair. Notice there's 2, makes it a pair. Each one is called a coordinate. So there are 2 coordinates in every ordered pair. Okay. So first, what I want you to look at is find point B and point to it in your book. Point B. Everyone should be looking at this spot right here. Point B. Notice there is a point, which is your point from our focus point, and it's labeled B. So we say point B. That's how we would label that. Okay. Now we want to write the ordered pair for point B. So if you look, I'm looking at number 3 right now in your book. me scroll down here so we can see it up here too. Okay, so I'm looking, here we go, number 3, point B. It says write an ordered pair to represent the location of each point. So point B, we start at 0. Remember, x comes first, so we need to go on the x-axis. How far over on x do we go? To 3. So our first coordinate is going to be 3. Then we do our y-coordinate. How far up do we go from there? 3. So we have a comma with a 3. So the ordered pair for point B is 3, 3. Now for that one, does it matter which order it's in? Yes, it does, but since it's the same number, it's hard to tell which one's x and which one's y. So try doing point D, which is number 5. See if you can plot point D. Tell me what the ordered pair is for point D. Okay, if we're looking at point D, I need to scroll up a little bit here. Oh, no, I don't. Never mind. Sorry, I thought it was up there. Point D is right there. Which coordinate always comes first? X. So I need to follow my x. And how far do I go over to get to point D? 8. So 8 is my first coordinate in this ordered pair. Then I would go up how many? 1. So 1 is my y coordinate in this ordered pair. Now for those of us that thought it was 1, 8, let's look at what that would look like. If it was 1, 8, we'd go over 1 and up 8. So that means it would be right there. Is that where point D is? Nope. Okay. So remember, your x comes first. So you always look at the x-axis first, which is horizontal, and then your vertical. Okay, let's go ahead and turn the page. You're going to see a blank coordinate plane. And then below it, you're going to see lots of different points that you can plot. Okay, but there's some information you need to know first. Okay. There are 3 different types of angles. That we're going to be talking about right now. Okay. There's acute, obtuse, and right. An acute angle, think of it as like, oh, cute. It's a small angle. It is less than 90 degrees. Okay. So an acute angle is less than 90 degrees. And obtuse, I think of obtuse. It's large. And obtuse is larger than 90 degrees. So if we have an acute angle and an obtuse angle that are both comparing to 90 degrees, what do you think a right triangle or right angle might be? A right angle is going to be exactly 90 degrees. Okay, so if you're wondering if an angle is exactly 90 degrees, you could always use the corner of a piece of paper because that's going to be a 90-degree angle. It's an exact 90-degree angle. It's usually represented by a box like that to make it a corner. Okay, so we're going to look at 3 different types of angles. Okay, and as you plot all of these, you would come up with bunches of different points on this coordinate plane. And then you can figure out, okay, which ones make an acute angle. So for example, if we plotted Q, V, and C, we would have plotted, see if I can get the smartboard to be accurate enough. Okay, those would have been those 3 plots. If we were to connect the dots, which kind of an angle does that create? So look at this hinge here. Is that larger than, equal to, or less than a 90 degree? It's less, so that would be an acute angle. Okay, it is smaller than 90 degrees. So this bend, this little elbow right here, this bend in that is less than a 90-degree angle. Okay, an obtuse angle might look like this. Let me erase this so I'm not blocking myself. P, Z, and R. Be 7, 10, 9, 7, and 8, 3. Okay, if I were to do these and connect the dots, look at this bend. Okay, that's obviously an obtuse angle. That is much larger than 90 degrees. Okay, so in your Think Central tonight, you're going to have these where it's going to ask you to tell, is it an acute, obtuse, or right angle? Okay, when you name an angle, the symbol for angle looks like that, and you name it in order that it happens. So this was P, Z, and R. So this would be angle P, Z, R is how you would label that. Okay, so in Think Central tonight, it's going to ask which angle is obtuse, and you're going to have to figure out which angle it is, and this would be PZR. Okay, so wherever your bend is, that's always that middle letter when you're looking at that. Okay, all right, and then finally going on to page 251. Go ahead and plot these 4 points on number 26 with your partner. Thank you. Okay, so we have 1, 10. So we're going to start at 0. We go over 1 because that's our first number, up 10. Okay, so there is point A. Point B is at 1, 7. So again, we start at 0, over 1, up 7. There's point B. Point C is 8, 10. So we start at 0, go over 8, up 10. There's point C. Point D is 8, 7. So we go over 8, up 7. And there's point D. If we connect all these dots, we get the shape of a rectangle. So now I want to challenge you to find the length of the rectangle. So if we were trying to find the length, let's say AB, we're looking just for that part. That's called segment AB, and it's written like this. That line above is segment, and then we're labeling it AB. So segment AB. If we were going to try to find the length of segment AB, what would we have to subtract? Think about it. We have B is 1, 7, and A is 1, 10. What are the only two numbers that are different are the Y coordinate. So if we subtracted the Y coordinate, we would get 3, 10 minus 7, which would be 3 units. If we counted those squares, are there 3 in between those points? 1, 2, 3. Yes. Okay, so that's one way to find. Yes, we can count, but if it was a really big shape, we could always subtract. Okay. Now to find segment AC, let's say we were trying to find segment AC. That one runs horizontally. So what would we need to subtract in this one? This one we'd want to subtract the x coordinates because our y coordinate is the same. Both of them are 10. So we'd want to subtract the x coordinates, which would be, for C it's 8, and for A it's 1. So 8 minus 1 would be 7 units. Okay. Then if we wanted to take it further, we can now find the area of that rectangle and all that. Okay. So tonight for Think Central, there's 16 questions. Some of them are just plotting points. Some of them are having a point and you tell me the ordered pair. And then there's some like this where you're finding the segments, the length of the segments.